Hello everyone, I am Bharat Singla and welcome to CodeChef. Here you'll find everything to learn and master competitive programming. So you know the drill with YouTube. If you have not subscribed yet, then make sure to subscribe to the channel to not miss any of the future videos. Great. Today let us discuss the problem chef in an infinite plane from CodeChef's July Cook-Off. This is a geometry based problem and this is the first time I'm taking up a geometry problem. So let's see how it goes. The prerequisites, there are no prerequisites, but the knowledge of pigeonhole principle and maybe frequency arrays will help you. Otherwise, that is not necessarily required. So the problem is that we are given an array of n integers, and then we want to, for each element, divide a of I into two integers, two positive integers, x and y, such that the sum is ai. So basically, break it into two numbers, and the two numbers will form a coordinate point. So we want to find the maximum number of distinct points that can be put into the plane if we optimally split all the AIs. So we can only perform one split for each element. So this is a note to use fast input output, and here comes the sample input. So we have two number of test cases. So the first test case is this array of six integers where we have 2, 2, 4, 4, 2, 6. So the way we can divide this is that for this number we can split it into 1 comma 1. For 2 we can again split it into 1 comma 1. For this 4 we can split it as 1 comma 3. Then the next 4 as 2 comma 2. Then again 2 can only be split into 1 comma 1 because both x y have to be positive. And then 6 can become 2 comma 4, 1 comma 5, 5 comma 1, 3 comma 3, anything. So as you can see, these ones, right, these are redundant, right? So the number of distinct points that we get is 4. For 16 and 8, clearly we can get two distinct points by splitting this into maybe 1 comma 15 and this into 1 comma 7. Right. So basically there are many ways which we could do. So we just need to report the number of distinct points if we split them optimally. So this is the problem. And now let us quickly jump on to the approach. Great. So say you have a number A and another number B. So if you split this A into x1 comma y1 and b into x2 comma y2, so basically x1 plus y1 is a and x2 plus y2 is b, so you split these two numbers. So if a is not equal to b, then can we have these 2 points equal? So the question basically decomposes into two main observations. This is the first observation, right? So if they are equal, so we can say that x1 is equals x2 and y1 equals y2. So let us remind ourselves, when are 2 points the exact same? So 2 points are congruent if x coordinate also matches and y coordinate also matches. This means more formally we can say that these two conditions must hold. So the x coordinate is also the same, the y is also the same. And by basic mathematics, let's solve this further. So if we add both the equations, we get x1 plus y1 equals x2 plus y2. And now this is nothing but a and this is nothing but b. Right? That was the criteria for splitting a and b, right? So after breaking it and then rearranging them and then adding them, we again get this equation. And this means a is equals b. But our condition was that if we are taking two numbers which are different, which are not the same, and we split them, can the coordinates be same? So no, by contradiction, we have proved that no. Any way in which I split a and b, the coordinates will never be the exact same. And this means that in an array, all the different values can be treated separately. We do not have to bother about the conflict of different points. So no matter how you split, say 3, so 3 and 7, right, and 5, say. So you have these three numbers. So 3 is split into say 1 comma 2. I am randomly splitting them. And if you take any way, you notice that the points will never come the same. And 7 maybe I can split into 3 comma 4, right? 5 I can split into, there are many ways. I split say this into 1 comma 4, right, or 4 comma 1, whatever I take, these points will anyways never be equal by this equation that we form now. And another way in which you can see this is that, say if the x coordinates match, so if 3 is broken into 1 comma 2, and 7 to match at least the x coordinate. We again break it into 1 comma, so the 1 matches, but then the next number would be different, right? Because in the end the sum is different. So this means that all the different numbers in the array can be treated separately, and for each of the numbers based on the number of time it occurs, we can sum up that to get a final answer. Great. So this was the first observation. Now let us move on to the second observation. So you have a number a. In how many ways can you split a? So a can be written as 1 comma a minus 1, right? In this case, they sum up to a. It can be written as 2 comma a minus 2, 3 comma a minus 3, so until a minus 1 comma 1, right? So these are all the ways in which a can be split into. For example, if you have say say 4, so you split this 4 into 1 comma 3. Great. Then in the array you encounter another 4. So remember that our goal is to maximize the number of distinct points. So the next 4 we must not split again into 1 comma 3. We must try something different. And for that all we have to do is simply take 2 comma 2, right? Then if we encounter another 4 in our array, we simply take 3 comma 1, right? So it also depends on the number of times 4 occurs in the array. Then if I encounter another 4, so this time, as you can see, there were three possible ways to split 4. So formally we can from here see that a can be split into a minus 1 ways, right? So yes, for 4 we have split it into 3 ways. And now if I encounter another 4, that is after 3, if I encounter another 4, there's no way I can split it into something unique, right? So I again have to split it into 1 comma 3 or 2 comma 2 or 3 comma 1. This means that after the number of times I can split a number that is given by a minus 1. All the future occurrences, all the further times I see that, they are all redundant and are useless basically. Okay, so if 4 occurs one times, right? So if 4 occurs one times, then I can get one distinct point. If 4 occurs two times, I can get two distinct points. If 4 occurs three times, I can get three distinct points. But if 4 occurs more times, so 4 occurs four times, right? In that case, again, I can only get three. If 4 occurs five times, again, I can only get three. And after this, we'll only get three. So if formally I can say that a number a, if the number a occurs t times, it can be split into minimum of a minus 1 and t. So this clearly means that there are a minus 1 ways to split the number, and if I have more occurrences, then I'll take the smaller one. If I have less occurrences, then again, even though I have much more potential to split it into more unique points, I do not even have the capacity, the number of frequency, right? The frequency in the array. So this means that if 5 occurs 3 times, uh, I'll take the minimum of 4 and 3, 5 minus 1 and 3. So this gives us 3, and yes, you will split 5 into 1 comma 4, 2 comma 3, 3 comma 2, right? After this, you don't even have another 5. So you take the minimum, right? Getting the intuition of why are we taking the minimum. And if I have 5 say 100 times, right, then anyways I can split it a maximum of 4 in 4 distinct ways, right? So I'll again take minimum of 4 and 100, all others are useless. Great, so this was the approach, and yes, we have reached the end. All that is left is building up the solution from these observations. So say you have the array, so let's take up the same array, right? So you have 2 2 4 4 2 6 2 2 4 4 2 6. Right. So pretty evidently we need the frequency of a number. So we'll use frequency arrays for that. So frequency arrays or a map, whatever you want to use, is simply storing the frequency of a number. Right. So it will be something like 2 occurs 3 times, 4 occurs 2 times, 6 occurs 1 times. Right. So this will be the map or array, whatever you want to use. And from this, how will we find the answer? So we'll go on the number 2. So 2 occurs 3 times, right? So this means that 2 can be split into how many ways? Well, it can be split into 2 minus 1 ways, which is 1 way. And yes, indeed, we can only split it into 1 comma 1, right? So we have one way to split it, but it occurs 3 times. So we'll take minimum of 1 and 3. So in our answer, which is was set to 0 initially, we can add 1 to it, right? We found one unique point. For 3, how many unique points can we get? Well, 3 it doesn't even occur, so we can just move on. We can go on to 4. 4 occurs 2 times. 4 can be split into 3 different ways, and we'll take minimum of 3 and 2, so we get 2. So yes, we can only split the first 4 into 1 comma 3, and the 1 comma 3, and the second 4 into maybe 2 comma 2, right? After this, we don't even have enough occurrences, so answer becomes, we add 2 to it, so it becomes 3 now. Then we go to 6. So 6 occurs 1 times. Number of ways in which we can split 6 into is 5, right? So 5 and 1, I take the minimum, I get 1. And yes, for this 6, I'll split it simply into 1 comma 5, right? So we can add 1 to our answer again, and this becomes 4. So finally we get answer as 4, right? And let's see what the answer was. And yes, it indeed was 4. Great. And again, remember that we do not need to take care if these 2 points could come out to be the same. Because as we discussed on the first observation, two distinct numbers cannot be split into 2 points such that they are equal. Great. So now let's move on to the implementation. Great. So let's start off with the code. So let's take the input for test cases and let's run a function solve. Right, so this will be a void function that will simply consider each test case as an isolated environment, and we'll do whatever we want to do for a given test case. So we have n, we input n, then we have a vector for an array of size n. Let's input it, right? And then what we want to do is we want to maintain a frequency map, right? So map is a bit easier here, right? You can also use an array. It's basically the same, just it's just that map is a bit more comfortable, and it works when the constraints are low enough. So we actually don't need an array, right? So this is some trick. So all you have to do is repeat something n times. So int I equals 0, I is less than n, I plus plus. You can have element, say an element. You basically, in the end, you only need the frequency, so you don't need to maintain an array. So let's have a map of int and int frequency. So frequency of I is the frequency of I. So we can say that map, sorry, frequency of element you can increase, right? So this gives us, so map frequency of 2 is now 3, frequency of 4 is 2, frequency of 6 is 1. Great. So this is creating the frequency array. And now let's have a variable answer initially set to 0. Now let's iterate on the map. So for that I'll use object destructuring in C++. You can search that up if you are not familiar with it. So I'll directly destructure it from a pair into two elements, that is the element and the frequency of element, and we iterate on the map. So in the answer, what I'll add is the minimum of the element minus 1, the number of ways in which it could be broken down, and then frequency of element. Okay. So let's finally output the answer. So so basically we take the input for n, we maintain a map for each of the n elements, we increase the frequency of that element, right? And then we have an answer variable set to 0, and we go on all the elements with their frequency, and the number of ways is elim minus 1, right? But if we have way too many frequencies of that element, then those are redundant. Whereas if we have very low number of frequencies of that element, right, then we can't even split all of them. We basically can't even utilize all the ways in which it could be split, right? So we are bound to take the lower one. So that's why we use the minimum function, and then we print out the answer. So let's test this and let's see what we get. So we get 4 and 2, and this seems fine. So yes, 4 and 2 was the expected output. Let's submit this and hope for an AC. So till then, one thing I would like to tell you is that if you are in the lookout to learn some new concepts from the best in the world, then all you have to do is go on to the Unacademy's website and choose your goal as competitive programming. So Unacademy is where CodeChef educators take live session, teach DSA, conduct problem solving sessions, and tell you everything about the CP world. So if you want to quickly get better, if you have some goal or you want to quickly get ready for your placement season and all, then it's great because you will get a structured path, and instead of learning random topics, you can learn everything in a channelized manner. So you will be taught by ICPC finalists and 6-star, 7-star coders. So hurry up, guys. This is the best opportunity for you. So just log on to an academy, create an account. You can also watch the free live sessions, and you can also go for the paid course where you'll obviously get much more benefits. Opting either for them, you can use my code Bharat27. Right. So this will help you register on the website. And if you opt for the course, the paid course, then you can also get an instant 10% discount through this. So yes, if you really want to see some sharp improvement, this is the best investment that you can make. Great. So now coming back. So yes, we do get an AC. If you have any doubts or queries or like the video, make sure to like the video and comment down anything related to it. This is Bharat Singla from CodeChef signing off for now, and I will see you next time.